Hi, what's going on, guys? Welcome back to my channel. Today I want to show you another advanced project that I did from Frontend Mentor website. So this one is going to be this Connect for application or game, whatever you want to call it. So I'm not going to go through the description here. I'm just going to show you the end result that I created. So here is the app. And the main functionalities for this app is just it's very straightforward. So you can play the game. So each time you click, the turn of the player is going to change, and you can see that we are playing the game until some player is going to connect 4 basically, and then win. And when he wins, the score for the player will go up. So let's try to make a win for a second, so I will show you. By the way, as you can see, when we place a chip, it doesn't matter where I click, it will be pushed by gravity down. So let's say that I click here, now I'm the yellow one. I hope you can see this yellow circle that I have on hover state. But anyway, you can see that now it's the yellow player's turn from this node over here. Let's click over here, and you can see that the chip went down all the way to the bottom. So now let's try to connect this diagonal with 4 reds. So let's keep clicking here. Let's place something here, and then we place the yellow one here. And now when I place the red one over here, the red player should win. So let's click here. And now you can see that the score went up, and we have a different message here that says player 1 wins. And basically we can play again, and so on and so on. And basically it's just a two people multiplayer game. I'm just going to go through the interesting stuff. So the interesting stuff here is to actually make the chips go down when I click on some kind of column. And another thing is to decide how the player actually wins. And to be honest, I cheated a little bit here. So the algorithm itself is calculating all the rows and the columns. By the way, this thing over here is just a one-dimensional array instead of 2. And I'm just doing a grid here with CSS to make it look like a 2D dimensional array, but I will show you in a moment. Anyway, the way that I compute the winning player is just by going through the board. So each time I click on the board, I will run a function to check if some player won. So I cheated a little bit, and I hard-coded the options for diagonals. So you can think about the winning possibilities. So let's say that we have this diagonal over here, and then we have this one, and then we have this one, and this one, and so on. And then we have the opposite. So we can go from this direction. So we have this diagonal and this and this and so on. And actually, it was a mess to calculate it on the fly. So I cheated and I hard coded it. So I'll show you in a moment. So yeah, let's go to the code, and let's actually first, in the last game that I made, I first started with the utils functions that actually contains the brain of the application, but this time I want to start with the components, with the app, with the state. We have also a custom hook here that is managing the board. So as you can see, this use game board is the custom hook. So first, as you can see the app here, so the app is going to take all the functionality from the from the custom hook that I made. We have some global styles, which is not very interesting. And here we have all the components. So the header component, the board wrapper that is displaying the board. And here we have player score, board, and player score. So basically these 3 components over here. And then at the bottom we have the footer. So we have the winner board, and the player turn kind of containers. So these are all the components, very straightforward. We are using emotion here to style everything and make it very organized. So let's look first at the components. Let's look at some of them because they are not actually interesting. They don't hold any functionality. They receive everything from props and just displaying the UI. So this is the purpose of the components to just display the UI and don't hold any functionality. So this is our board. So as you can see, I'm getting the board, which is a one-dimensional array, and I'm just mapping. So I'm displaying the chips. Here you can see that the display, the grid wrapper is a grid. And with the grid, I can say that I want 7 by 7 rows and columns. And this way I avoided to make it a 2D dimensional array. So just to note here. So other components are really not interesting. So we have button, we have chip, which is going to be displaying some different colors and states depending on the props that the chip receives. Header, player score, player turn, again some very basic UI stuff, and winner board, which you saw before. Okay, so let's go to the interesting part. Let's start with the custom hook that I made. So in hooks, we have use game board. By the way, you can see that all the structure and everything is very similar to the game that I made the video before, which was a memory game. I will post a link in the description if you want to see it, but you can just go to my channel and check the latest video beside that one. So yeah, so let's go in a very high overview on this custom hook. So we have just a bottom border here, which is 6, that I'm creating a constant that you will see why we need to check if we are at the bottom of the board. We have some states, so very basic, the board, the current player, is game finished, which player won and player score. And here we have the on restart function. And the interesting function is the on chip click. So again, I want to go very quickly to overview this function. Okay, so on chip click, first of all, we have some conditions that I don't want to do anything. So if the game is finished, I just want to return. And here we have set board, which is basically going to set a new board state. And we receive the previous board from the state. At the beginning, just to note that at the beginning, each chip is going to hold a null. So this is when I create the board, I placed all the values to be null by default. So we check if the value is not null, I just want to return the board state, which actually means that if I click on this thing, nothing is going to happen. So I just return the previous state. But if I click on this thing, this chip is not going to be null. This chip is going to be null, and this one is not going to be null. This one is going to be either, I think, a yellow or red value. I made this project a few weeks ago, so I'm not sure, but if I click on this value is null, and now it's changed to red. Same for this, now it's changed to yellow, but if I click on it one more time, nothing is going to happen from this check. So here we check the empty position in the current X column and take the bottom one. So this functionality is what making the chips go down all the way. So if I click, for example, on this one, the chip will be placed here. So we have some if statements here we have a loop, first of all, to check if to check the Y position, and basically we are going until we reach the bottom of the board. And if we are going to meet in any of these conditions, we're going to break from the loop and to set the board to its proper state. So we can look at this logic later if you want, but just in a quick overview, this is what it does. And here we have check if the new board state makes the player to win. So here is where the complex logic is actually sitting. So we have player 1, which is going to be check for player win function. And we pass it the board state. So to check for a player win, by the way, this is just some another basic logic. So if the player won, I just want to set some states and so on. But to check for a player win, we need to go all the way to the utils folder, and this is where the actual algorithm checks what I said before. So we're checking all the possible rows, all the possible columns, and all the possible diagonals. So now let's look at this function. So in the utils, we have this index thing. And as I said, I cheated a little bit with the diagonals because it was very hard for me to actually calculate it computedly, like programmatically. So I actually gave up and just made it an array with all the possible diagonals in the board. And this is an issue if we had some different board sizes, that I actually had to make a few options like this for diagonals, but we have only one size, so 7 by 7. So I just looked at the indexes and yeah, I did it hard coded. If you have any idea how to get these values programmatically from the board, it will be very interesting to see. So you can tell me about it in the comments or whatever. But here, anyway, let's look at the generate board, which is just going to create the board with the needed state, so you can see each time. So anyway, we are looping through the chips, and we're creating, and each time we're pushing these objects with value of null by default, the position and the index. So this way, we are having the compute, like the board state ready for use, and we return the board. So this is the function that actually checks for player win. So as you can see, for rows and for columns, I can pretty much easily make a for loop and to get the rows programmatically, because I can filter by the chip position y in this case. That is going to be the index, and I can make rows pretty easily and check each row if I'm using this function check for 4 in a row on the row itself. So this is pretty easy to do. To check the columns is also pretty easy to do. I just filter by the position of x, which is going to be index, and I pass the column each time. And of course, if I have a match, so if I have 4 in a row for rows or columns, I'm just going to set the player 1 to the string of the player that won. So I think it's red or yellow, but not. We can check the type later, but yeah, you know what? Let's do it at the moment. So yeah, I was correct. So it's either the value is either red or yellow. So let's go back to our function. So here is the small cheat that I did with diagonals. So I'm just looping through the diagonals and I'm passing. I actually have to create the state for the diagonals, because I need the indexes are not enough. So here I have only the indexes, but I do need all the state of the chip. So I'm getting the board chip. So the computed diagonals are going to be the board chips in the index position that I'm passing. So yeah. And here again, I'll do this check for 4 in a row with the computed diagonals, because I actually need all the values from the chip to be able to do it. And I'm returning back the player 1. So by default, the player 1 is going to be null in this line. And if some of these conditions if some of these conditions are true, then I will return a string with the winning player. So the last function here is the actual function that checks 4 in a row. So I'm just going to get an array of chips. I'm going to return either a string or a null. So current value, again, it's going to be null. And we have here counter that actually checks if we have 4 in a row, and then we do a for loop here. So for each chip, I'm going to check if the value is null. I'm going to reset the counter. If the chip.value is not equals to current value, I'm going to set the current value to the chip value and reset the counter. But if the chip value is equal to the current value, I just want to increase the counter by 1. And if the counter is equals greater or equals to 4, so if we have 4 values, if we have 4 values in a row, basically, then I want to break from this loop. If the counter is greater or equals to 4 here, so after the loop, I want to return the current value. So basically, the current value, so it can be either red or yellow from this for loop. And yeah, so I return the current value. Otherwise, I return null because we don't have 4 in a row. So these are the algorithms that I created. I know it's very naive ones because I'm checking all the board each time the board is the state is changing. I'm checking all the columns, all the rows, all the diagonals. It's a very naive approach, but as I said in the previous video, I'm not very good with algorithms. There must be much better ways to do these calculations. But yeah, so I hope you enjoyed this little video. I hope you learned something new. Actually, my plans for the next ones is to do some stuff with Svelte and SvelteKit because I was very disappointed with Next.js 13 version. So I decided if I want to create a full stack application, create a SSR application, I don't want to learn Next.js 13. I think SvelteKit is actually a better approach because first of all, React is already kind of old technology, and Next.js is built on top of React, and Svelte is much more performant, much more developer friendly. There are also much less boilerplate and stuff like that, and there's been a long time that I wanted to try Svelte, and I think now it's a good opportunity to also try to learn it and post my progress. So stay tuned, and I will see you in the next video. If you're new, please subscribe. I'm very close to 1000, so it will be great to reach this goal. And yeah, if you like it, please like the video, and I will see you in the next one. Bye, and thank you for watching.